Okay, we're now moving on to the problems 16 through 30 on your final exam review. So we're starting with number 16, which is multiplying complex numbers. And you start the exact same way you would start if they were just regular polynomials. We're going to multiply every term. So 1 times 1 is 1. 1 times a negative 8i is a negative 8i. 5i times 1 is 5i. And 5i times a negative 8 is a negative 40i squared. So I can combine like terms here. So I have negative 8i plus 5i is a negative 3i. So I have 1 minus 3i minus 40i squared. And then hopefully you somewhat remember from when we learned about complex operations that because the definition of I is the square root of negative 1, so I squared, if I were to square these would cancel, and I squared is just equal to negative 1. So I can replace this I squared with a negative 1, so I have negative 40 times a negative 1, which is 40. So I have 1 minus 3i plus 40. And now I can combine these two because they're real numbers. So I have 41 minus 3i, which is letter D. Numbers 17 and 18 are solving radical equations. The biggest thing to remember when solving radical equations is you have to have the radical by itself before you can square both sides. So on this one, I've got to get rid of this 3 first. So if I minus 3 from both sides, then I'm left with 8 is equal to the square root of 11k plus 9. And then now that this radical's by itself, in order to get rid of it, I can square both sides. So that cancels this radical, and 8 squared is 64 is equal to 11k plus 9. And then I can subtract 9 from both sides, and I'm left with 55 equals 11k. Divide both sides by 11, and 55 divided by 11 is 5. So k is equal to 5, which is option A. Number 18, the radical is already by itself, so that's the most convenient way to do this. So I can go ahead and just square this to get rid of it. But if I square this side, I have to square this side, and all of a sudden both my radicals cancel out. And I have 29 minus 2n equals n minus 10. So in order to solve for n, I'm going to try and get all the n's on one side and all the numbers on the other side. So I'm going to add a 2n to both sides. And I'm going to add 10 to both sides. So then those cancel. So on this side I have 29 plus 10, which is 39. And then I have n plus 2n, which is 3n. So all that's left is to divide both sides by 3. 39 divided by 3 is 13. So my answer is A. On numbers 19 and 20, we are writing a polynomial. And I'm going to go ahead and only show you one of these because I think that once you see one, you'll be able to do it. So these are the solutions to my polynomial. So like x is equal to negative 4, x is equal to 0, and x is equal to 4. So I'm going in reverse order to try and find the factors of my polynomial. So I want each of these to be equal to 0. So this one is already equal to 0, so x is one of my factors. This one, if I add 4 to both sides, then I'm left with x plus 4 equals 0. So that's one of my factors. And then on this side, if I minus 4 from both sides, then x minus 4 equals 0. And that's one of my factors. So each thing that I've circled are my factors. So if I multiply them together, so I have x plus 4 times x minus 4. So I'm just going to do 2 at a time. So I start by doing x times x is x squared, and x times 4 is 4x. So those two are multiplied together. And then I just multiply that by my third factor, which is x minus 4. So x squared times x is x cubed. X squared times a negative 4 is a negative 4x squared. 4x times x is a positive 4x squared. And 4x times a negative 4 is negative 16x. So when I combine like terms, negative 4x squared plus 4x squared, that's just 0. So those are gone, and I'm left with x cubed minus 16x, which is option D. And we'll go ahead and quickly view the answer for number 20 so that you can see if you get it right when you try it. So number 20, the answer is B. So go ahead and try number 20 until you get the answer of B. And then we'll move on to the last page of multiple choice. So we're starting with number 21. And each of these, they're all factoring problems, but they're factored in different ways. So the first one is the one I think you're most accustomed to. We've got to find two numbers that multiply to AC, add to B. So multiply to this, add to this. So our AC is 1 times 24, which is 24, and our B is 11. So two numbers that multiply to 24 and add to 11 are 8 and 3. And because A is equal to 1, there's no number here, then I can immediately see that this factors to x plus, I guess, n plus 8 times n plus 3. So in order to find my solution, since this says to solve by factoring, I set each of these factors equal to 0. So if I set n plus 8 equal to 0 and n plus 3 equal to 0, I minus 8 from both sides, so n equals negative 8, minus 3 from both sides, n equals negative 3. So the answer to this is option D. Number 22 only has two terms, so I should have mentioned this on number 21, but the first thing you should always do when factoring is see if there's a greatest common factor you can pull out, and in this case there is. Both of them have a v, so I'm going to factor out a v, and then I'm left with v plus 3. And notice I now don't have v squared or v cubed or v anything. They're all, my v's are by themselves, so I can right from here set each factor equal to 0. So I set v equal to 0 and v plus 3 equal to 0, and I minus 3 from both sides, and v equals negative 3 and 0, which is option A. Number 23 is actually very similar to number 21. You're just missing your b term. So if you don't have anything to the x power, we have x squared plus 0x minus 49. So then I just need two numbers that multiply to negative 49 and add to 0, which in this case is 7 and negative 7. So this factors to x plus 7 times x minus 7. And if I set each of those equal to 0, I get x equals negative 7 and 7, which is option B. Number 24, I think, is the one that tends to throw people off the most. And it starts the exact same way we started 21 and 23, but then we have to do a couple extra steps in there. So I start first by seeing if there's a greatest common factor I can pull out, and in this case there is not. So I go to my A times C is 2 times 25, which is 50, and my B is negative 15. So two numbers that multiply to 50 and add to negative 15. Well, if they're going to multiply to a positive number, it has to either be two positive numbers or two negative numbers. And it's got to be two negative so that they can add to a negative 15. So I know that both my numbers are going to be negative. So what are two numbers that multiply to 50 and add to 15? I would say negative 10 and negative 5. So if I were doing one where A is equal to 1, then I could just say x minus 10 and x minus 5. Unfortunately, A is not equal to 1. A is equal to 2. So I'm going to use these two numbers to replace my middle term, like so. So I have 2x squared, and then instead of minus 15x, I have minus 10x minus 5x plus 25. And then over here, I'm going to group this side, group this side. Over here, I can factor out a 2x, and then I'm left with x minus 5. And I don't ever want my x to be negative, so on this side I'm going to factor out a negative 5, and then I'm left with x minus 5. And then fortunately my parentheses match. So my first factor is x minus 5, because that was my parentheses terms. And then my second term is the 2x minus 5, because that's what was left. And then if I set each of those factors equal to 0, just like I did in the other ones, I end up with x equals 5 and x equals 5 halves, which is option C. 25 and 26, we're still factoring, but these ones it's just asking us to factor, not to solve. So I'm going to show you number 25 and let you try 26 on your own. Both of these have 4 terms, so I'm going to factor by grouping. So I'm going to group this side, group this side. Of these 2 terms, I can factor out an x squared, and then I'm left with x plus 2. And on this side, I can factor out a 2, and I'm left with x plus 2. So again, my parentheses match, so my first factor is an x plus 2. My second factor is x squared plus 2. And that's the end. Option A. So we'll go ahead and check out the answer for 26 so that you can check yourself when you try it. So 26, the answer is C. So try it and see if you can get answer C. 27 and 28, we are simplifying. So in order to simplify effectively, I need everything in factor form. So fortunately, we just reviewed factoring. So I need 2 numbers that multiply to 24 and add to 10. And this time I'm not going to write down my whole ACB thing, but the 2 numbers are 6 and 4. 6 times 4 is 24, 6 plus 4 is 10. And since A is equal to 1, my top factors to m plus 4 times m plus 6, and the bottom factor is already factored as much as it gets, and it's m plus 4. So m plus 4 over m plus 4 is just 1, so I can cancel that out, and all I have left is an m plus 6, which is option D. 28 is very similar, except to factor the top, I'm going to pull out a greatest common factor. So I factor out a 6, and then I'm left with m plus 2. And the bottom's already factored as much as it can get with an m plus 2. So then these cancel. All I have left is a 6. 29 and 30, we are solving rational expressions, and in order to do so, we have to have common denominators. So if I look here at number 29, to find a common denominator, I want to include everything from these denominators. So this has a 3 and an n, so I know I'm going to need at least a 3 and an n. Oh, and this one has an n squared, so I'm going to need 2 n's. And this one has an n squared, but I've already included that. So this right here, 3n squared, is my common denominator. So I need to make each of these denominators have a denominator of 3n squared. So to get this 3n to be 3n squared, I need to multiply it by an n. So I'm going to multiply this by n over n. This denominator is already 3n squared, so I'm done with that one. This one has the n squared part, but it's missing the 3. So I'm going to go ahead and multiply. N times 1 is just n over 3n squared. And then plus 1 over 3n squared equals 1 times 3 is 3 over 3n squared. So now that all of my denominators are the same, I can just worry about the numerators. So I'm going to go ahead and cancel out all my denominators, because if I were to multiply both sides by 3n squared, my denominators cancel out anyways. So then I'm left with n plus 1 equals 3. Which is a very simple solving problem, so I'm going to minus 1 from both sides, and n equals 2, which is option C. And then I'm going to start you on number 30, but I may have you finish it on your own. So to find a common denominator, I know I'm going to need a 6 and an n, and then this one has an n squared, and then this one has a 3 in it, but since 3 goes into 6, I'm good. I don't need to add the 3, and it already has an n. So to get this to 6n squared, I multiply by n over n. This one's already 6n squared. To get this 3 to a 6, I need to multiply it by 2, and then it only has one n, so it needs another n. So then I'm left with n over 6n squared plus 1 over 6n squared equals, oh, I got to multiply by 2n over 2n, which is 2n over 6n squared. And at this point, you can just cancel out the bottoms and just worry about the top. And I'm going to let you finish it, but I'll show you the answer you should get is D. So try that problem and try and get answer D.